All right, let's talk VLANs. You know, if you've spent any real time in the networking trenches, you know there are two kinds of networks: the clean, orderly, segmented kind, and then there's the other kind, the kind that gives you nightmares. I've seen them both, and today we're going to crack the code on how VLANs can take us from total chaos to complete control.
So here's the game plan. First, we'll dive into the mess we're trying to fix, that chaotic flat network. Then we'll bring in the hero of our story, the VLAN. After that, we'll pop the hood and see how they actually work. Check out some special purpose VLANs, and then we'll wrap it all up with some pro-level strategies to really lock things down.
Okay, Section 1, the chaotic flat network. This is ground zero. This is the Wild West, where every single device on your network is in one giant room, all shouting at each other at the same time. Trust me on this one, it is an absolute recipe for disaster.
So let me just ask you straight up, does your network ever feel like this? Just a tangled, chaotic mess where one little hiccup can bring the entire operation to a grinding halt? If that sounds familiar, well, you're not alone, and you're probably dealing with what we call a flat network.
Let's talk about the symptoms, because man, they are painful. I once saw a single, badly configured network card on a laptop create a broadcast storm that took down an entire office. Total paralysis. And security? Forget about it. It's wide open. A breach on one device can spread everywhere. And trying to manage it, moving a user means you're literally in a closet physically repatching cables. It's just not scalable, it's not efficient, and it is definitely not secure.
But okay, enough doom and gloom about the problem. Let's start talking about the solution. Section 2, VLANs to the rescue. This is where we, as network admins, start to bring some much-needed order to all that chaos.
Now, the most important word in this whole definition is logical. A VLAN is a virtual local area network. This means we don't care where a device is physically plugged in anymore. We're working at layer 2 to basically draw virtual lines, chopping up one big, noisy, insecure network into multiple smaller, quieter, and way more secure networks, all using the same physical switches.
And this is the why. This is where it gets good. Remember those broadcast storms? VLANs stop them dead in their tracks by keeping broadcasts contained. That massive security risk? Now we can create separate, isolated zones, one for finance, one for guests, one for engineering. And moving an employee? It's now just a couple of clicks in a software interface, not a physical cable hunt. And maybe the best part? We do all of this on the hardware we already own. It's a huge win.
Okay, so we've covered the what and the why. Now let's get into the how. How does this magic actually work? Well, it all comes down to two key concepts: ports and tags.
This is absolutely fundamental. You've got two main flavors of ports. First, the access port. Think of this like the driveway to a single house. It belongs to one and only one VLAN. It's where you plug in your PCs, printers, you name it. Then you have the trunk port. The trunk is the multi-lane superhighway that connects all your different neighborhoods, or VLANs, together. It's how your switches talk to each other.
And what's the secret sauce that makes this superhighway work? It's this right here, IEEE 802.1q. You can just call it .1q. This is the industry standard for VLAN tagging. It's like the universal language that lets switches from any vendor all understand which traffic belongs in which lane. So let's follow a piece of data on its journey. Your computer, which knows nothing about VLANs, sends a normal data frame to its access port. Let's say it's on VLAN 20. The switch sees it, and before it sends it down a trunk link, it injects a tiny 4-byte tag into the header that basically says, hey, this belongs to VLAN 20. That tagged frame travels across the trunk. The next switch reads the tag, knows exactly where it's supposed to go, and forwards it only to other ports in VLAN 20. Right before it leaves the final access port to the destination PC, the switch strips that tag off. The end devices are completely oblivious. It's brilliant.
So why this specific number? Well, that tiny tag has a 12-bit field for the VLAN ID. If you do the math, 2 to the power of 12 is 4,096. We lose a couple for reserved purposes, and that leaves us with 4,094 usable VLANs. That little tag unlocks a massive amount of segmentation power.
All right, now that we've got the fundamentals down, let's get into the more advanced stuff. Think of these as the special forces of your VLAN toolkit, because you quickly learn that not all network traffic is created equal. A perfect example of this is the voice VLAN. We've all been on a choppy, robotic-sounding phone call. That's what happens when voice traffic gets delayed. So we create a special VLAN just for our IP phones.
The really cool part is that the phone itself is smart enough to tag its own voice packets, putting them in the express lane while letting the data from the computer plugged into it just pass through on the normal data VLAN. Seriously, pro tip, always put your voice traffic on its own VLAN. It will save you so many headaches.
Okay, so here's a curveball. You've got a bunch of devices, and they all need to be on the same network subnet to talk to the internet gateway. But for security, you absolutely cannot let them talk to each other. What do you do then?
The answer is something really clever called a private VLAN, or PVLAN. This lets you create little sub-VLANs inside of a normal VLAN. The classic example is a hotel. Every guest in every room needs to get to the internet through the hotel's main router. But you sure as heck don't want the guest in room 101 to be able to scan the laptop of the guest in room 102. That is a perfect job for a PVLAN.
The magic of a private VLAN comes from these different port types. You've got your promiscuous port. That's the one your router plugs into. It can talk to everyone. Then you have isolated ports. These are your hotel rooms. They can only talk to the promiscuous port and nothing else. And finally, you have community ports, which can talk to each other and the promiscuous port. It gives you this incredibly granular control, all without having to burn through your IP addresses.
All right, last section, and this is a big one. Let's talk strategy, because setting up VLANs is one thing, but securing them like a seasoned pro, that's what separates the amateurs from the experts.
Okay, let's talk about something that trips up a lot of admins, the native VLAN. I love this simple explanation. On a trunk link carrying all that tagged traffic, there's always one special VLAN that's allowed to cross without a tag. It gets a free pass. This is the native VLAN. And while it's needed for some legacy stuff, it's also a potential security nightmare.
And here is exactly why you need to worry about it. By default, on almost every switch out of the box, the native VLAN is VLAN 1. This is a huge, well-known target. Attackers can use crafty techniques like VLAN hopping to send specially formed packets that trick switches into letting them jump the fence from this untagged VLAN into another, more sensitive one. This isn't just theory. This stuff gets exploited. It's a backdoor that so many people forget to lock.
So, how do we lock this down? Here's your checklist. Number 1, change it. Get the native VLAN off of the default VLAN 1 immediately. Number 2, isolate it. Move it to a completely unused VLAN ID, a black hole that has no users, no servers, nothing. Number 3, be consistent. Make sure the native VLAN ID matches on both sides of a trunk. And finally, the ultimate pro move. If your gear supports it, just configure it to tag the native VLAN too. This completely closes that untagged loophole.
So I want to leave you with this final thought. VLANs are an amazing, powerful tool for bringing order and security to your network, but they are not a set-it-and-forget-it technology. You have to manage them actively. Things like the native VLAN are critical details. So go back, look at your configurations. Have you really sealed up all the back doors? Because a well-managed network is a secure network. Thanks for your time.